So continuing on, we need to give our final answer now. That would be, therefore, x is less than -2, or x is greater than or equal to 4. So that's a two-unit method. Now let's look at the same question, but let's do it using the extension 1 method, which is pretty straightforward, and hopefully you'll find it quite easy. So we start off with 6 over x minus x plus 2 less than or equal to 1. Now, here's the issue. If I'm not going to turn it into an equality and just try to solve this, what I need to worry about is when you multiply both sides by a negative number, the sign needs to swap, needs to flip the inequality sign. Now, if I have x plus 2, that can sometimes be positive, sometimes be negative. But if I multiply both sides by the square of x plus 2, then I overcome that problem. So on the left-hand side, I end up with 6 x plus 2 at the front, less than or equal to, and 1 times x plus 2 squared is x plus 2 squared. And this way I've multiplied both sides by a positive, resulting in not having to worry about the two cases that arise. Then we expand. That gives me x squared plus 4x plus 4, and rearrange. So that gives me x squared minus 2x minus 8 is greater than or equal to 0. Hopefully I got that right. So can I factorize that now? X, what about if I have take away 4, x plus 2, negative 4 times 2 is -8, -8, 4 plus 2 gives me my -2, so that works out nicely. So I end up with x equals to 4, x equals to -2. So you can see we end up with the same result, but slightly different method of going about it. Now, if you have a look, what I have here is a quadratic, which I could graph. Now, I'm not going to worry about drawing the y-axis, because I'm really interested in the x-intercepts. But the y-axis would go through 0, obviously. Let's say that's -2, that's 4. The coefficient of x squared is positive, so it's a concave up graph. And what I'm looking for is for when this graph has y values greater than 0. And it has y values greater than 0 in these two regions. So therefore, the solution is x less than -2, or x greater than or equal to 4. And again, it is essential to note at the beginning that x cannot equal to -2.